Alright guys, in the last few videos, I have laid out Maxwell's problem number 3. I've done part A and part B, which was determine the error terms, which we've done right here, and determine the trend function, which we've done right here, and it's modeled by this. We know that the time series point prediction at each point can be predicted using this equation right here. So since we have the trend component, we can now find the seasonal component, which is essence of t is how they represent it in the book. So you know the seasonal component is going to model daily high temperatures, with the hottest month being August, and the coolest month, I guess, being one sinusoidal period, or 1/4 of a sinusoidal period after August. And with that in mind, and with how the properties of sines and cosines, and knowing how they work, we can use that to determine the seasonal variation model. So in the instructions, they say that the average daily high temperature is seasonal with a total seasonal spread of 40 degrees. So let's write all these down. So total seasonal spread of 40 degrees. Doesn't even matter if it's Fahrenheit. The hottest month is August. And as of April 1st, the daily high temperature is 77 degrees. I guess that's a little bit too far. It's going to be working into the trend. Okay, so working off of this, we can use a sine function to model this. So we know that total seasonal spread is going to be 40 degrees. So that means the difference between the very hottest month and the coolest month is going to be 40 degrees. You know that a sine function is going to have this amplitude of 20. If you do 20 times sine of whatever, of x, let's say. But that's going to be like positive amplitude. And if you extend that out and make it like one period after, it's going to have positive and negative amplitude, which gives it so a negative 20 at the lowest point. So the difference between positive 20 and negative 20 is going to be 40 degrees, obviously. So we know that the first part is going to be 20 times sine, which is going to be the coefficient of the sine function. We also know that the hottest month is August. So from that, we can mess with the inside of our sine function in order to shift it so that the hottest point, which is the highest point of the sine function, will be in August. Okay, so we know that August is going to be t equals to 4, right? We also know maximum point of the sine function is going to be at pi over 2. So, knowing this, you can come up with this equation, pi times t over 12, over 6, minus pi over 6. And this allows you so that if you have t is equal to 4, the inside will be equal to pi over 2. And that gives you the maximum point of the sine function with this total seasonal spread of 40 degrees, which is 2 times this coefficient right here. So plugging this into Excel, you can do 20 times sine of... So Excel doesn't actually recognize pi, at least it doesn't on this computer. So I'm going to use 3.14 as like sort of a pseudo pi value. Multiply that by A2. Divided by 6. Minus... And this gives you the seasonal variation for a specific t. You can expand this out so that you can get the seasonal variation for the rest of these. I mean, obviously you're not going to have Excel on the test, but the same idea is going to work. You basically just plug in this t value right here for each t, and this time it's going to be the terms of months, but you can do it in terms of years or whatever it is that they give you, and you should get these values. Notice that the seasonal values right here is not actually 20, even though that the coefficient is 20, and that's probably because I used 3.14 right here instead of like the actual pi value, so it's kind of like an estimation, but that shouldn't really matter. I mean, you guys get the point. So that is how you calculate seasonal. In the end, they ask you to calculate the simulated time series value for each time, and how you do that is you just basically add up the seasonal component, the trend component, and the error term of each one. So in order to do that, we can do this in Excel pretty easily. Just do d2 plus, and we can use this to expand it. And this should be our simulated y sub t time series point predictions for each given t. Thanks guys, good luck on the test.